Maria Montessori believed children have a preference for structure. She believed that children are born with human tendencies, which include order and precision. And these are the foundations for making sense of mathematical ideas, which is an ordered, logical discipline. Therefore, Maria Montessori said that these human tendencies for structure meant a child's mind is mathematical in nature. She believed that young children can understand their world through classification, such as ordering, comparing, and matching. And by using concrete materials to explore these ideas, they start the foundation upon which abstract thinking and knowledge is later built.
It's very often that you'll have, like in a traditional school setting, there'll be a time in the day schedule when we're going to do these group activities. And oftentimes like organized games and music will happen in these full group experiences. In our Montessori classrooms, though, they don't often happen that same way. It's just like any other part of the classroom. If you have a class space that's really individualized, the presumption that any two children in the room will be ready for the same lesson at the same time is very small, right? I mean, particularly if the way that you're individualizing lessons comes down to like whether or not they've had that argument with mom. The idea of like scheduled group games or scheduled songs to learn together is a little distinct for me from what happens in the Montessori spaces that I enjoy. But to the degree that being playful with each other and engaging joyfully with each other in creative new ways is a human nature, that happens all the time.
Embedded in the Montessori approach is that hands-on experiences are essential for a deep understanding of mathematical concepts. Maria Montessori used the term materialized abstraction to describe how children understand an abstract idea by experiencing it in a hands-on way.
So materialized abstraction is when a child works with materials in the setting to support them with their learning.
The perfect example of materialized abstraction, particularly when it comes to maths, would be in the binomial or trinomial cubes, because that is a concrete form of algebra.
They will have objects to touch and feel and to work out the mathematical equation using objects rather than being an abstract thought and having to work it out in their head.
So it's algebra made concrete and visual. The child is able to take apart the binomial cube, and as they take it apart, they name the different parts of that cube. So they very quickly realise that algebra is about adding things that are similar but can be grouped easily. And so they will build the binomial cube, and then they will follow that up by learning the formula. And they may not necessarily apply the formula until they're, 10 or 11 years old when they're doing it further up the school. But the visual learners will have had that early concrete image and experience of holding and touching the binomial cube, so that if they're finding algebra challenging at the time and the formula challenging, they will have something to go back to.
The Montessori materials may be unfamiliar objects to young children. Therefore, it's important that children learn the language of numeracy and arithmetic by applying it into their everyday lives, such as moving from counting out objects during play to setting the table at lunchtime.
So very similarly with literacy, lots of songs, rhyming songs, they use number songs like 10 green bottles, those sort of things. You would have more objects around when Montessori, when you're teaching those, you wouldn't just have the songs, you would have objects to show the children the physical 10 green bottles, one smash, and they would see it actually happen. So we tend to link the songs with actual physical activities when we're doing that, and the children can, again, a materialised abstraction, I suppose, that they're actually seeing the objects and understanding what they are, understanding what's happened, and linking that song to that rather than just singing the song and not understanding it.
So first, the development of understanding of numbers and quantities 0 to 10. This is one of the things that's I think lovely, fascinating part of Montessori, is that it's not 0 to 10 to start with, is it? It's 1 to 10. And in fact, it's 1 to 9 first. Because 0 is its own magical function. We have to understand the existence of quantity before we can understand its absence.
Children in a Montessori classroom, when coming across numbers 1 to 10, are introduced to a series of lessons. So each lesson has a different purpose. And I think one of the clearest examples of this is the spindle box, because the only lesson that they are learning at the time is quantity. So it's understanding that 1 is a smaller quantity than 9. But when you're a small child and you've only just been introduced to the numerals 1 to 9, understanding that 8, when you're looking at it printed on a piece of paper, is bigger than 1 when probably both symbols are about 2 inches high is quite confusing. So Montessori printed these symbols onto a box with slots in it and had 45 spindles, because that's the control of error. So when the child walks away, it's not just a bunch of spindles. They'll know when they've made a mistake and they'll know how to correct it.
So Montessori starts with numerals and quantities as separate concepts. And you have to understand the numerals separately, just as we introduce the sounds that the phonetic alphabet makes through sandpaper numbers that the child can touch and hold in their hands as they're building the vocabulary of numerals. And then quantities separately. This is 1, this is 2, this is 3, 4, 5, 6, 7, 8, 9, and then the combination of those things.
But they'll start off by having a review of those numerals that they've learned, and then they're introduced to 0. And quite often the teacher will say, and this is 0, and 0 means nothing. So what do you think we're going to put in this box? And the child will say, look at you as if you've come off Mars, and say, nothing. And you go, great, fantastic. Right, let's go to the next one. They'll pick up the spindle, put it on the table before then picking it up again and putting it into the slot. Because by the time we get up to 8, one of the first things that a child of 3 or 4 who's got quite a small hand will automatically say in picking up all those spindles is, wow, that's a lot. And as soon as they say that, you know as the teacher that they've got it. They understand quantity and they can move on to the next activity.
And they learn through lots of materials, 0 to 10, about learning what the quantities are, understanding what the quantities are, rather than just abstract knowing the numbers and in order. So they won't always learn them in order. They might learn them in a different order so that they understand what that number means and what the quantity of that number is.
A great example of place value can be seen in the golden bead activities. So in Montessori's time, these golden beads were really beautiful because they were made of Murano glass. And you started off with 1 unit and you went up to 1,000 units, which were cubed because it's 1,000 is a cubed measurement as well. And there literally are 1,000 beads on it.
A lot of schools don't learn place value in early years, but in our early years we do. With the Montessori, we use the golden bead. Again, it's physical activities, so you will have the place value on a board or a piece of material, and the children will place the material underneath the heading of hundreds, tens and units. But before they've done that, they will have learnt what each unit is, before they then place it.
We don't get to 10 until we're ready to talk about place value, because 10 doesn't really matter until you understand that a 10 is different than a unit. 100 is different than 10. And 100 is not actually its own special magic word. It's 1 again. 1 million, 1 billion. It's still 1. And if I understand the numerals and quantities from 1 to 9, I can do the numerals and quantities from 10 to 90 very easily, because 1 10 or 9 10s or 7 10s. I can do thousands just as easily. I can do 3,000th, and if I have a concrete that shows me what 1,000 is, it doesn't matter that I haven't yet counted all the way up individually, because the 1,000 is still one unit of thousands. These pieces become cumulative. So now I can do place value really easily.
When we look at the numerals that go alongside that, we'll talk initially about the units, which are green, and then we'll have cards with tens on it, which are blue, and then hundreds, which are red. And then we have green thousands. And quite often teachers, when I'm first introducing them to this activity, will say, why have we got green again? What was the theory behind that? And Montessori wanted the child to know that we were then talking about units of 1,000. So if we went on and had tens of thousands, they would be blue, hundreds of thousands would be red. And then once the child goes off and gets a tray and you've given them a 4-figure number to go and collect in their numerals, they'll trot off to the other side of the room and come back, and we'll have to tidy them all up. And so straight away we have our 4-figure number minus all the zeros.
Once children are comfortable using and understanding numbers to 10 and have been introduced to the associated materials, they can begin exploring the 4 operations: addition, multiplication, division, and subtraction.
They are introduced to them through physical objects. So they will, with addition, they will have objects that they will use to add up. And again, with the takeaway, same thing. They will have objects that they will take away, physically take away. And they'll move on to, so they'll start with loose objects and they'll move on to fixed, so that they will know how to take away loose objects, and then a bit harder is to take away a fixed amount. So you've got something there, so 10 fixed objects.
When we get to group operations, so being introduced to addition, multiplication, subtraction, division with large numbers, small children, and I'm talking sort of probably 5 or 6 year olds even, can be introduced to adding 4-figure numbers, because we've got these wonderful concrete materials in the golden beads and the large numeral cards. So initially they will lay all the large numeral cards out on a mat, all the golden beads out on a mat. They might at this stage have been given a sum card, but initially they'll just be given a number and a quantity to go and get. And if you're doing multiplication and you're multiplying by 3, then you'll have 3 children involved in the equation. So it becomes a social activity, and they go off and get the same. Obviously, if we're talking about multiplication, they'll go off and get the same quantities, the same numerals each. And we'll point this out to them. Oh gosh, you've got 1,420 and you've got 1,420 and so have you got 1,420. Isn't that amazing? Do you think we can multiply them together and find out what the answer is? And they look at you as if you've slightly come off Mars, and any parent who's watching you is now wondering what on earth you're going to do. But they very quickly realise as we go through the activity that multiplication is just a question of adding the same number each time. So it is, for young children who love those big numbers, it suddenly takes away the scariness and makes it a very exciting thing. And I know that in a lot of Asian cultures, numbers are revered in a way that maybe we don't in the Western world. And I think the more I've seen of that and families who have talked about numbers in an exciting way has just generated so much more passion and love of maths in a young child.
These exercises can be carried out with individual children or in groups. The group activities allow for peer support and enables children with different levels of understanding to work together. It also adds an important social aspect to the child's experience of numeracy. The International Montessori Institute works in partnership with education professionals in all sectors, from early years settings through to higher education providers, to create a unique, child-centred approach to education. The Institute is a partnership between the Carnegie School of Education at Leeds Beckett University and the Montessori Group. It supports the development of accredited Montessori programmes and actively researches the impact of the Montessori method. The Institute's research themes are very much rooted in the work of Maria Montessori and how to improve professional practice in order to enhance the educational experience of the children. For more information, go to leedsbeckett.ac.uk/IMI. And don't forget to join our conversation with our 3 Twilight sessions and conference in June. You can also follow us on Twitter and Instagram.